In this video, I'll introduce the idea of object-oriented programming and show you an example of how it can help you streamline code. Let's say you have a program that needs the quadratic equations a lot. Let's say this could be the physics engine for a game where you have a lot of things flying, projectile motion, and so you need to solve quadratic equations a lot. You might want to make functions that'll tell you, find the value, it finds f of x for a particular quadratic, or solves for x when a quadratic is a certain y value, or maybe you want to just print out the quadratic function in a nice, pretty format, and so you have a couple functions. And so here's how your program would look. You would make you would enter the coefficients of the quadratic equation you want. One is it'd be ax squared, so 1x squared, 1x minus 6. And then you can call your functions. And you pass it the a, b, and c, and it'll make it look pretty, and so forth. Let me print this out. Run this. And there it is. It printed out nicely. It found f of 1, and it found the x values when y is 0, or the zeros. So this works just fine. And this is the way we've been doing programs before. But what object-oriented programming does for you is it allows you to bundle up the data, in this case it's the a, b, and c, with the functions. It'll put the data together with these functions into one object. If you think about in Python other things that are objects, like strings are objects, they have data, like what the contents of the string is, and they also have functions that are associated with strings, like length or upper, and those are methods. The string is the object. And by combining those two things together, you can just take a string, put dot upper, and have it convert, and it knows what the data is, so it knows what to do. Here, we're going to do the same thing with a, b, and c as the data. We're going to put the data together with the value. So here's how it looks with an object-oriented programming. You create a class which describes how quadratic works. The first little bit, I'm not going to go into details, just stores the a, b, and c in with this object, in this one instance of an object. I'll talk about that in a little bit. But you notice inside quadratics are also these functions, the same functions we used before, and it's kind of, all this stuff is put together. The data is stored, a, b, and c are stored, and the functions are all in the same place, and now these are called methods. So we'll have a quadratic object. An instance of a quadratic object is, like here's one particular instance where a is 1, b is 1, and c is -6. And so we made an instance of the object called q. And now when we just call q, if you want to print it, the object knows how to print itself. It makes this pretty little formatted string, and it prints it out. When we call q.value, this is a method. Oh, this is a quadratic method, the one that we just made. All I have to do is pass it x now. Remember before we had to pass it a, b, and c, and x? Here, we don't have to pass it a, b, and c because q knows what its a, b, and c are, because that's how we initialized that instance. And you don't have to pass a, b, and c again. It knows it, and it'll look it up, the values that it needs to solve that value function or method. And it does the same thing with solve. So this thing works the same way, and it looks identical. It prints it out nicely. It finds the y value, and it finds two x values of the zeros. So let's talk a little bit about how it works, just kind of conceptually. Okay, remember I said you don't have to pass it a, b, and c. Well, how does it know what a, b, and c are? Well, here, since this is a method, we tell it we want the instance q. So right now, Python is going to say, well, let's find the value as it relates to q. Okay, so here's what's going to happen. When it goes to value method, it comes up here, and it'll run this. And it'll pass it x, but it also has to know which instance of this quadratic function are we talking about? So that's what the self is. It says, oh yeah, we're using q. So we have this word self means it's going to look up q's a multiplied by x squared, and then q's b times x, and then the value of q's c. So this is a little bit weird getting used to, but this self really just means use my own a, use my b, use my c in here. And what this does now is makes it real easy to work with, let's say, a second copy. Let's say we want to have a Q1 and a Q2. And now we have a different quadratic object, and we can put in the new values there. Actually, let me just cut and paste it. I have it in my clipboard. We put new values of a, b, and c in there. Now we have two different quadratic objects. So I can just make a loop. I can go through, first time around I'll go to Q1, second time around I'll go to Q2, and I can do all these things. And now, first time around, this is Q1, so when it runs the method value, it'll go up and say, aha, we're using Q1's a, b, and c, let's return that, and it returns that value. And now, look how clean it is to work with two different functions. Now it prints the first function, finds a function value, and finds zeros, and it does the same thing with the second. And I'm not having to pass around a, b, and c's because they're just together. So when I'm using Q2's value, it knows what a, b, and c are related to Q2. Another example of where this would be wonderful is, let's say we wanted to make up a new class, and we'll pass it two things like the slope and the y-intercept. We didn't define this yet, that's what's giving me an error, but let's say we want to make it so that everything seems to work the same way with linear functions as they do with quadratic. So I might want to have set up my class, so linear1 dot value could be it could look just the same as the quadratic function value. So I can make a method that works for for linear equations and not have to give it a new name. Now think about how you'd have to do it the old way. This is if I had regular functions. I might have to call this value of a quadratic. And then I might have to make a new function, value if it's linear. And this would get quite messy because now, since every function is just on its own, it's not bundled together. So I'd have to keep track of this with names or some other way to figure out which value I'm trying to talk about, the value if it's a quadratic function or value if it's linear. But here, if I make a linear class, just like I made a class quadratics, and I'm not going to go into all the details here. I'll have the same type things, et cetera, et cetera. But I would have then a method, and this method would work for linear equations. So I'd solve linear equations in here, and that's how this would work. In this case, the value is specific to if it's a quadratic, this value is specific to it's a linear equation. So just kind of lumping the data and functions together make it a really, really clean way to organize your code.